Hello, dear students. How are you? I hope that all of you are good. So here we are with the question discussion of AIET 3 JEE question paper. This is for 11th grade, and we are discussing the difficult question in this question paper. So just move to the very first question, and I hope that all of you have attempted it. Now, in this question, if you see the velocity v in centimeter per second of a particle is given in terms of time by the equation v is equals to AT plus B upon T plus C. Now, the dimensions of A, B, and C are. So basically, to solve these types of questions, the first thing that we have to keep this in mind, that same dimensions can be added or subtracted. So to add a physical quantity, the another quantity must be C. So same physical quantities or same dimensions quantity can be added or subtracted. Okay. So based on this concept, we are going to find out the dimensions of A, B, and C. Here, if you will see in this equation, B is equals to AT plus B upon T plus C. So firstly, if you focus on this term, the denominator of B upon T plus C. So these two quantities are added, which means the dimension of this time must be equal to the dimension of C. So here we find out the dimension of C because these are the quantities which is going to be added, which is being added in this. So same dimensions can be added or subtracted. So must have a dimension of time. Now we have find out what is the dimension of time. Sorry, what is the dimension of C? Now the term comes for AT plus B upon T plus C. Now these two quantities are also adding up, and this is equals to velocity, which means these two quantities combinedly represents a velocity. So we can say that V is nothing but A into T, and V is also equals to B upon T plus C. Now, if you compare the dimension formula, what is the dimension of velocity? It is LT minus 1 equals to dimension of A into dimension of T. Now, you can take this T here on the left hand side, the dimension of A will become LT minus 2. So this quantity is also termed as acceleration, but we are not talking about that. So dimension of A is LT minus 2. Dimension of C we have find out, dimension of A we have find out. Now we have to find out the dimension of B itself. Now you just compare with this equation, write the dimension of velocity or speed. This is velocity, so LT minus 1. Same dimension we have in terms of speed also. Now, what is the dimension of B? We used to find out. And what is the dimension of T plus C? It is also time because this combinedly representing time. Here we will add it T. So B would be LT minus 1 into T, which is given by. So dimension formula of B is L. So here A, B, and C, we have find out the dimension of A is LT minus 2, dimension of B is L, and dimension of C is 2. Option C representing the correct options. Option C is the right. Now, the kinetic energy of a particle moving along x-axis varies with its position x, as shown in figure. The force acting on the particle at x is equals to 10 meter is. So here the graph that is provided to us is energy and distance graph. Okay. So this axis represents the kinetic energy, this axis represents the displacement of particle. Okay. Or the position of particle, you can say. Now, how to find out the force acting on the particle at x is equals to 10? Look, if you remember that, we can say that work done is nothing but force into displacement. Okay. Or if we are talking about a very small work, so you can write it as f dot dx. Now, we also know that according to work energy theorem, change in kinetic energy equals to also work. The total work done is also change in change in kinetic energy. So if you compare these two equations, you can say that this dk, which is for small work, is equals to f dot dx. If you focus on this part, na, dk by dx represents the force, and dk by dx is nothing but slope of kx graph. And here the kx graph is given to you. So at x is equals to 10, the slope is what? So for that, you need to calculate the slope of this portion. And this is a straight line. This coordinate will become what? 40. Sorry. X coordinate, firstly, you have to write at 8. And then y coordinate is 40. And for this, the x coordinate is 10. And y coordinate is 20. So we can mark them as x1, y1 and x2, y2. So what is the slope? Slope is given by y2 minus y1 by x2 minus x1. Now y2 is what? 20 minus y1 is what? 40 divided by x2 is what? 10 minus x1 is what? 8. So this has become minus 20 divided by 10 minus 2 is what? 10 minus 8 is what? 2. So it is coming out to be as minus 10. Okay. So if you talk about the slope at x is equals to 10, this also same as the slope of this complete line, because line is a straight line. So slope must be constant for that. Okay. So this is how the point that we have write it here. Na? This is for 12. So it will be 12. So x2 minus x1 will become 12 minus 8. Okay. And 12 minus 8 is 4. So this will become 5. Okay. Minus 5. What is this minus 5 means? If you will see, the slope is what? Decreasing. It represents a decreasing slope. And decreasing slope का मतलब हुआ, the force is also in negative direction. So we can say force is minus 5 I cap Newton. Clear? And why minus I cap? Because this energy is given in terms of displacement about x-axis. So that is why the force is also acting in the x-axis. Okay. Now, so option D is the correct answer. Now move on to this question. If the velocity v of a particle moving along a straight line decreases linearly with its displacement s is 20 meter per second to a value approaching to 0 at s is equals to 30, the acceleration of the particle at s is equals to 15 meters. The same thing is here also. Here you are given with a vs slope. Okay. And you see that this graph is a straight line, representing straight line. So if you write the given data here, initial velocity, let's say represented by u, is 20 meter per second, and final velocity v will become 0. This initial velocity at which value of displacement? At s is equals to 0 according to the graph. S is equals to 0 पे what is velocity? 20 meter per second. And at S is equals to 30 meter, what is the velocity? 0. So acceleration is being asked of the particle as S is equals to 15 meter. Okay. Now, if you apply the equation v square is equals to u square plus 2ax, as we know that velocity is decreasing, which means acceleration is acting in the negative direction. So we are applying the equation from 0 to 30 meter. So finally the velocity will become 0. U square is 20 into 20 plus 2 times of minus e, because the velocity is decreasing, multiply by 30. Now this becomes 400 equals to 2 into 38. 1010 cancel out. 20 by 3 minus 20 by 3, okay, is the value of acceleration. Clear? If you are not applying the minus here, since you are applying the minus, you are clearly saying that acceleration in the opposite direction of velocity. So that is why this result is coming out positive, because you already assume the acceleration in the negative direction. But let's say you haven't assumed the direction of the acceleration. Then if you will see, this will come out as minus 20 by. Okay. Clear? So which options to be choose? So for that, you have to see the velocity is increasing or decreasing. So velocity is decreasing. So that is why acceleration is also acting in the negative direction. So we can say option D is the correct. Now at x is equals to 15, you would think about it that you have calculated it between 0 to 30 meter. But as you can see, the acceleration is constant, is coming out constant, not depending on time. So that is why it is fixed. And as you can see, this is Vs. We know that acceleration is dv by dt. ds by dt is a multiply divide. Then ads is equals to vd, which means dv by ds, the slope of vs graph, it represents the ratio of accelerations to velocity. Clear? If the slope is constant, then this ratio is also constant. And we can say the slope is constant here. So that is why this ratio is also constant. So you can calculate this value by this equation also. Here the coordinate will become 0, 20. And here the coordinate will become 30, 0. Now apply m is equals to y2 minus y1, x2 minus x1. What is y2, y1? You can assume by yourself. I am considering that this is x1, y1, x2, y. Now y2 minus y1, 0 minus 20, x2 minus x1, x2 minus x1 is 30 minus 0. So m is coming out to be as minus 2 by 3. And which is nothing but acceleration by velocity, minus 2 by 3. Okay. So if you put the value of velocity here, the initial velocity, which is 20, and multiply it, then you also calculate this slope. So acceleration by velocity time the slope will be coming out as minus 2 by 3. It's representing that acceleration is also constant and the velocity is also constant. Now this one. Find the maximum value of f such that there is no relative motion between the blocks. Okay. So here in these types of question, first of all, you have to find out what is the limiting value of friction. Okay. When you know the limiting value of friction, then you can apply the formulas. Okay. But why we need to find out the value of limiting friction? So that we would know that how much minimum force that we required to break that friction. Okay. So first of all, to solve these questions, Solution is given by, let's say, first of all, draw the FBD for 5 kg block. So here we have a downward force, which is of 5 into G, an upward normal reaction, let's say N. Now, since this force F is trying to pull this force in the forward direction, so friction will definitely act in the backward direction. We can calculate the value of friction, let's say, what is mu into N. Now, mu you have to take this one, 0.4, which is the friction between 5 and 10 kg block. So it will be 0.4 into what is the value of N? And you have to take this 5G. 5 into 10, so it is coming out to be 20 Newton. So the friction that is acting between 5 kg and 10 kg block is 20 Newton. Now, if you talk about 10 kg block, let's say draw the 10 kg block here. This is 10G. Upward side may we have normal reaction. And let's say this is N dash. Now, one more force is there. This force, this particular block is placed over a 10 kg block. So it is also pushing it down. So that is why an additional force of 5G is also down. Or you can say that here, if you will see, this 5 kg block is pushing down it. So this is also applying a reaction force, and that is in terms of N. Okay, clear? Now, N dash is equals to 15G. If you calculate the friction in this case, will be mu dash into N dash. Mu dash is 0.1, N dash is 15 into 10. So it is coming out to be 15 Newton. Now, if you draw the force on this 10 kg block, this is the gravitational force, let's say 15G total, because 5 kg was also placed on it. This is normal reaction N dash. So as this block is having a friction in the backward direction, so this block in the, according to Newton's third law, this action has an equal and opposite reaction. That is why this force is coming out in the forward direction. Or this block try to move this particular block with itself. So that is why it is pushing itself in the backward direction. Now, there is one more force, the force of friction between the surface of the block and the block itself. Let's say this force is F dash F1 that we have calculated. Okay? Because this force F is trying to push this block in the forward direction. That is why this F1 force is acting in the backward direction. Clear? Now, if there is no relative motion between them, you just keep this in mind. On this block, which only the frictional forces are acting, firstly, you need to consider that. So here, if you will see, F minus F1 is equals to mass of 10 kg block into acceleration A. What can be the possible acceleration of this block? So it will be 20 minus 15 is equals to 10 into A, which is coming out to be 0.5. Means that this particular block can have a maximum acceleration of 0.5 meter per second. In opposite to that, this particular block, if this 5 kg block is also accelerated with the same acceleration, then we can say the relative acceleration between these blocks are 0. Okay. So we can apply the equation over here. Phi F minus F1, capital F minus small f, is equals to what? Mass into acceleration. Now this equation you can write like this. This friction can have a maximum value as limiting friction. So if this particular frictional force is having its maximum value, then this force is also having the maximum value. So F max is equals to F limiting. This is 20 Newton. Mass of the block is 5 into acceleration of the block is 0.5. And this will coming out to be as 22.5. Okay. So maximum this force can be a 25 Newton. Now, move on to the next question. Two particles are rotating in the same circle with constant speed 10 meter per second and 5 meter per second in anti-clockwise sense with their initial radii vector being separated by an angle pi by 2 as shown in figure. Find the time at which they will collide. So very simple question. These are the velocities given to you. Just find out the velocity of A with respect to B, VAB, because the speed of A is greater, so it will reach the B first. Okay. So VAB we can write VA minus VB because they are in same direction, so they will subtract. So it is 10 minus 5 is equals to 5 meter per second. Now what is the separation in between them? That is a trick question. Most of the student will apply this as a separation between them. No, the separation which A has to travel. Now we are seeing the motion of A with respect to B. So only A is moving, B is in rest. So A has to travel this much distance to reach B. Got it? So we can say that SAB is equals to 3 by 4th of 2 pi r. 3 by 4, 2 pi into what is the value of r? R is 4 upon pi. Pi and pi got cancel out. 4 and 4 will cancel out. So it is coming out to be as 6 meter. Now, B is equals to S upon T. So VAB is equals to SAB upon delta T. Now delta T will be SAB. SAB की value is 6 upon VAB is nothing but 5. So it is coming out to be as 1.2. 1.2 second. Option C is the correct. Okay, in this question, two statements are given. The first is the work done by friction is always negative. The second statement is if frictional force acts on a body, its kinetic energy may decrease. Look, the work done by a friction. Suppose we have a block and this block is moving in this direction. So frictional force will act in the opposite direction. Suppose this particular block is moving on incline and it is moving downward. So frictional force will move upward, applied on the upward side. If this block is moving like this, then the friction will always act opposite to the relative motion. So frictional force always opposes the relative motion. Okay. But whatever the displacement that we are traveling with any kind of force, the frictional force is always acts opposite to the displacement. As you can see here, here, and here also. We know that work done is nothing but force into dot product of displacement, which is Fd cos of theta. So the theta angle, the angle between frictional force and the displacement vector is always 180 degrees. So that is why the work done is coming out to be as negative, which means the work done by the frictional is always negative. This option is correct. This statement is correct. Now, if frictional force act on a body, its kinetic energy may decrease. That just verified. So this work done is given by change in kinetic energy. And this work done by the total forces. So let's say work done by conservative force, work done by non-conservative force is equals to delta. Non-conservative force is friction. And we see that the friction work is negative, which means that it is somehow decreasing the value of delta T. So this statement is also true. But the explanation of statement 1 is not correct. Okay. Both statements are true, but they are not the perfect explanation for these statements. So we can say that statement is true. 1 is true and statement 2 is true. Okay. And statement 2 is not the correct explanation for the statement. Now, this one. A particle of mass m oscillates along a shell A and B inside a smooth spherical shell of radius capital R. At any instant of the kinetic energy of the particle is k, and then the force applied by the particle on the shell at this particular instant is x by xk upon capital R, where x is a number. Find the value of x. So we can, because in this question, if you will see that it is saying that at any instant, which means we can take anywhere value. So in these types of question, try to find the easiest way to calculate this, because you have to apply the energy conservation to solve these types of questions. So trying to find out the two very easy positions. So the first position we are considering B, and the second position we are considering. Okay. And we are applying conservation of mechanical energy. Now kinetic energy initial plus potential energy initial is equals to kinetic energy final plus potential energy final. Now we are starting the motion from here. So these are the extreme position in oscillation, and in extreme position the velocity is zero. So that is my we can say the initial velocity or the initial kinetic energy is also zero. But if you see, let's say this is the reference level, and this is what? Capital R, the radius. So what is the initial potential energy? Let's say the mass of the particle is m, which is also given in the question. So potential energy is mgh, which is mg into r. Final kinetic energy at this particular instant is k. We are assuming it k, plus potential energy final at this particular instant is 0. So we have k is equals to mg into r. This is equation 1. Now we have to find out the force at that particular instant. Is this particular instant way? We have to find out the force. So let's say this is the book. There is a force of weight which is acting in downward direction, and there is a normal reaction also which is acting in the upward direction. And this normal reaction is nothing but the centrifugal force, if you will pay attention to it. So we can say that F is equals to mg. This n is equals to mg, and n is nothing but mv square upon r, which is mg. Okay. Now m and m will cancel out, so v will become g into r. Okay. So velocity we have already find out, but it is asking for the force applied by the particle on the shell. So force कितना apply किया है particle ने on the shell is given by this force. This is applying the mass force of it in the downward direction. So mg is equals to mv square upon r. ठीक है. Now the force applied by the particle on shell. So this force is mg. The mg force is only force which is applied by the particle. N is the reaction force. So we can say it mg multiply by r divided by r. Mgr is nothing but kinetic energy k, so k upon r. Because we have to find out the force in terms of xk upon r. So the value of x is nothing but 1. Okay. Now this one. Very good question. A man of mass 75 kg is pushing a heavy box on a flat floor. The coefficient of kinetic and static friction between the floor and the box is 0.20. And the coefficient of static friction between the man's shoes and the floor is 0.8. If the man pushes horizontally, what is the maximum mass of the body that he can push? Okay. No problem. So first of all, we will write the given data. Given data is mass of the man is 75 kg. Okay. And mass of the block we want to know. Mass of block is, let's say, m. Okay. The coefficient of static and kinetic friction is also given. What is the coefficient of friction? So let's say mu of block, mu b, is 0.20 and mu of men is 0.80. Now, let's say this is the man. So on the foot of this man, the frictional force is acting because this is trying to move up in the forward direction. And there is a normal reaction also on the man, and there is a frictional force. So can you calculate the frictional force? Yes, we can. F is equals to mu into n. And this will be mu of man into normal reaction generated by the ground to the man. So mu of man is 0.80 and n is equals to mass of the man into gravitational. 0.80 multiplied by mass of man is 75 into g is 10. So it is given by, if you multiply it, will come out 600 Newton. So maximum, the limiting friction that is acting on the man's foot is 600 Newton, which means if the applied force that it is applied on the block, if the applied force exceeds this value, the man going to slip. Okay, clear? So that is why we can say, if you draw the FBD of the block, this is block, and I am just shifting the force vector. This is the force that this man is applying to push this particle or push this block. You can have this also. I mean, you can represent it like this. Now, if the block is moving forward, the frictional force on the block is acting in the backward direction. Okay. So we can say that here, let's say this force is F. So the maximum weight that this particle can have is F is equals to small f. Okay, because this is the equilibrium condition. So F is equals to what? If you calculate the limiting value of the friction over here on the block, it's mu into n, which is mass of the block into gravitational acceleration, and it is 0.2 into m into g. Okay. Now, the interesting thing is here, this particular man can push this block without any acceleration. So that we have to consider by ourselves. Okay. So if we draw the FBD that a man can apply maximum this value of force. So we can say this F minus F is equals to 0, because this F has to work against this force. So if you put this force equals to this force that the man has applied equals to the frictional value, and this force is nothing but the frictional force that man has to overcome, and it is 600 Newton. 0.2 multiplied by m into 10, 0. So it is coming out to be at 30 kilogram, because finally it is coming out to be 300 Newton. So the maximum mass that it can push is 30 kilogram. Okay. Now, one end of a string of length L by 14 by 9 meter is fixed and a mass of 1 kg is tied to the other end. The ball is given a velocity 2 root gl at the bottommost point as shown in figure. The string is when the block becomes horizontal. String is cut when the balls become horizontal. Find the distance traveled till it stop for the first time. So here the situation, this block, this particular ball given a velocity root 2gl. So it is going like this. And when it becomes horizontal, this is the horizontal position. At this point, the string is cut. So when the string is cut, the pole move in the tangential direction, and tangential direction is this. So this motion will be like, okay. So at this position, it will stop for the very first time. Got it? Now at this point, what is the velocity we have to find out? Then we can easily find out what is the distance traveled by the pole. Okay, when it stop for the very first time. So first of all, here the given velocity is 2 into root gl, which we can also write as root 4gl. Now, if you apply the conservation principle of energy, applying principle of conservation of mechanical energy. So we can say kinetic energy initial, potential energy initial, kinetic energy final, potential energy final. Initial kinetic energy is 1 by 2 mv square, and v is given to you, which is 4gl. If you square root this, initial potential energy is 0 because we are considering the reference level here. And from here to here, the ball is moving in this direction. This particular position is length L. This displacement is length L only. So final kinetic energy, let's say, will become 1 by 2 mv square. Here the velocity is becoming v. So final kinetic energy is 1 by 2 mv square. Final potential energy will become mg into L. Okay. Now this is 2 mgl and this is mgl. So it will become mgl only, equals to 1 by 2 m v square. M and M will get cancelled out. So velocity at this particular point is coming out to be as what? Root 2gl. Obviously, it is decreased because some of the portion is converted into potential energy. So at this particular velocity, what maximum distance in the vertical direction it can cover? So we can apply the equation of motion here, which is v square is equals to u square minus 2gh. Now v will become final velocity, initial velocity is this. So it is root 2gl ka square will become 2gl equals to 2g into h. 2g and 2g will cancel out, h is coming out as L. So L is the, and L is nothing but 14 by 9. So 14 by 9 meter is the distance that, or this is this distance when the string is cut. But what about this particular distance? This also has to be taken care of. So this particular distance we can say is 1 by 4th of the circumference of this particular circle. So this distance is nothing but 1 by 4 into 2 pi L, because radius is L. Okay. 1 by 4, 2 into pi into L is 14 by 9. This is cancelled out. Pi की value we can take 22 by 7. 22 by 7 into 14 by 9. And there is one more 2 also here. So 2, 11 and 7 to the 14. 11 to the 22 by 9. The total distance it has covered is 22 by 9 plus L is what? 14 by 9. Now 22 and 14 is 6. And this is 3, 36 by 9, which is 4 meter. Okay. Now move on to the next one. A particle move along x-axis from x is equals to 0 to x is equals to 5 meter. Under the influence of force given by F is equals to 7 minus 2x plus 3x square, the work done in this process. It's very simple, by the way. Work done, since this force is not constant, so we can apply this work done, dW. Small work is done for a very small displacement, and then we integrate it for limits. And let's say at x is equals to 0, the work done is W1, and at x is equals to 5, the work done is W2. So net work done is W2 minus W1 is equals to integration of 7 minus 2x plus 3x square dx, 0 to 5. Now just integrate it, it will become 7 into x. It will become minus 2 by x square by 2, limits are 0 to 5, plus 3x cube by 3, limits are 0 to 5. Then 2 and 2 will cancel, 3 and 3 will cancel. For the limit 0 to 5, 7 into 5 minus 2 into 25 minus 0 plus, no, this 2 also cancel out, only 25 minus 0. And this is 125 minus 0. Here it is 35 minus 25 plus 1. 35 minus 25 is 10. 10 plus 125 is 135. So this is the answer. Now move to the next one. Okay. So in this question, an object of mass 10 kg is projected from ground with a speed 40 meter per second at an angle of 60 degree with horizontal. The rate of change of momentum of the object 1 second after its projection in SI unit is. Look, the very important concept over here. This is the projectile motion. This is the initial velocity, u. Okay. Now, let's say after 1 second, if you calculate the time of flight, t is equals to 2u sine theta by z. So 2 into 40 sine theta is 60 degree. Sine 60 degrees root 3 by 2. So it is coming out to be 40 root 3. 40 into 1.732. 17.3 multiply by 4. 4 3 is 12. Okay, g is also here, na? 2u sine theta by g. Sorry, there is a little mistake over here. By 10. This and this will cancel out. So it is 8 into 1.7 approximately. We can say 8 7 ja 56, 8 1 ja 8 plus 5, 8 plus 5 is 30. So approximately 13.6 seconds it is taking to complete this projection, which means after 1 second it is somehow here at this particular point, and the velocity will changes to v. Okay. Now, the one method is you can find out the velocity at this after 1 second. Vy is equals to uy plus ay into t, which is uy is nothing but u sine theta, which is 40 root 3 by 2 or 20 root 3. So you can say 20 root 3 minus 10 ay acceleration in acting in the downward direction, g into time is 1 second. So it is 20 root 3 minus 10, which is 34.6. Root 3 की value is 1.7. Multiply by 20 is 30.6. So it is coming out to be 24.6 meter per second. Ux will remain same as Vx because there is no acceleration on horizontal direction. So momentum is nothing but V final minus V initial. So the final velocity minus initial velocity you have to calculate. This is the one method. Now, the another method is also we have. Second method, we know that force is given by change in momentum per unit time. So if delta t is 1 second, The force is nothing but delta P, change in momentum. And in this projectile motion, the force that is being acting is mg always. Only the gravitational force is acting, and this is not changing. So whatever the force we have initially, the final force is also same. Got it? So you can say that the rate of change of momentum is nothing but mg, and m is 10 and g is also 10, so it is coming out to be 100 what, kilogram meter per second. Okay, now this one, two blocks b1 and b2, mass m1 and m2 respectively, are connected with the help of a pulley and string are shown. Upper surface of vehicle is smooth but vertical surface is rough. Given A is equals to G by 7, M1 is equals to 7.5 times of M2. So coefficient of friction between block B2 and the side of the vehicle is N by 10. Then find it. Because this particular surface is rough and this surface is smooth. Now we cannot apply the Newton's law directly into it because this frame is accelerating itself, which means we have to consider the pseudo force over it. So if you consider this B1 block, there is a tension force acting on it, and the force which is pseudo force also acting on it in the opposite direction of the motion. This pseudo force is given by, for this particular block B, mass of B1 into acceleration of the system. Mass of B1 is m1, acceleration is, let's say, and A key value is given by G by 7, so it will be coming out mg by 7. This is pseudo force. Now for B2, if you will see, this is B2. B1 is heavy because B1 is M 7.5 times of M. So if B1 is heavy, so this B2 is not going downward, B2 is going upward. So the frictional force act in the opposite direction of the motion. Tension will be acting upward. There is a mass M2G is also acting downward, but there is one more force. The normal reaction by this block, by this vehicle to the block, it is acting in this direction. And there is a pseudo force also in the opposite direction, which is Fs of B2. So Fs of B2 is given by, let's say Fs2 is mass of B2 into acceleration of the system. Mass of B2 is M2, so it is M2G by 7. Now for equilibrium, we can say this N is equals to Fs2, and the frictional force is also, let's say small f1, small f. Frictional force is given by mu into N. Mu we have to find out. N is what? Fs2. Fs2 is m2. So mu m2g by 7. Now for equilibrium condition, vertical forces are also 0. So T is equals to m2g. Now T is nothing but equals to, in this particular process, this is also equals to T1 for equilibrium. So T is equals to m1g by 7 equals to m2g mu m2g, mu m2g by 7. 7 will cancel out. M1 by M2, M1 by M2 is equals to mu. Now M1 by M2 is what? Sorry, one more force that we are missing here is this. Let me write it over again. The vertical forces that we are talking about now, it is P is equals to, one force is M2G and another force is frictional force. Now this is M2G plus frictional force is mu M2G by 7. Okay. And this tension force is M1G by 7. Now, if you multiply this complete equation by 7 and cancel out is this G, so it is coming out as M1 is equals to 7 M2 plus mu m2. Okay. Now m2 will, you can take common. So m1 by m2 is equals to 7 plus mu. M1 by M2 is 7.5. So we can say that 7.5 is equals to 7 plus mu. So it is 0.5 is equals to mu. We can write that mu is equals to 5 by 10. So if you compare it with n by 10, the value of n is 5. So the value of n here is 5. Move on to the next one. A stone is projected from the ground with a velocity of 45 meter per second at an angle 30 degree. It crosses the wall after 4 seconds. If the distance beyond the wall at which the stone strikes the ground is m root 3 by n, find the then find m plus n. Okay. Let's say this is the projectile motion. It is happening. And after 4 seconds, it crosses a wall. Let's say wall is here. This is a wall. And at t is equals to 4 seconds, it crosses the wall and travel this distance. So first of all, we find out what is the distance traveled till 4 seconds in horizontal direction. So we can say that given data mein, first of all, we will write velocity is given. So ux and uy you can calculate. Ux is u cos theta. U is 45, cos theta is 30. So it will become root 3 by. Uy is u sin theta. So 45 by 2 meter per second. And it is also meter per second. Okay. Now Sx at 4 second is ux into t because there is no horizontal acceleration. Ux is 45 root 3 by 2 plus t, which is 4 seconds, multiply by 4. So it is 45 into 4 divided by 2 into root 3 meter. Now what is the total distance? So for that you find the range. Range is u square sine 2 theta by g. U square is 45 into 45 multiply by sine 2 theta is sine 60, which is root 3 by 2 into 10. So 5 2 ja 10, 5 9 ja 4. So it is nothing but 45. Where is this 2 coming? There is not 2, only g. So 45 multiplied by 9 root 3 divided by 2. Okay. Now, if you just subtract it from the complete range, total range, if you subtract this portion, so what you will get? You will get only this. So small s that we required is r minus s. R is 45 into 9 root 3 by 2 minus sx is what? 45 into 4 root 3 by 2. Now, this is 45 times of 9 times of 45 root 3 by 2. This is 4 times. 9 minus 4 is 5. So it is 5 into 45 by 2 into root. If you compare with this m into n, the value of m is this and value of n is this. Just multiply it and you will get the answer. So for m, it is coming out to be 5 5s are 25, 5 4s are 20, 225 divided by 2. You just add it and that get the value. The concept is that first of all calculate the distance traveled by 4 seconds. Okay? Because at 4 seconds it is crossing the goal. Okay? And then after whatever the distance it has traveled, calculate that. Okay. So I hope you got it. I hope that you have enjoyed this session. After this session, if you have any kind of doubt regarding this AIET examination questions also, you can connect me in the regular classes. Thank you so much, guys. Take care of yourself. Bye-bye.